Can a plant keep photosynthesizing in continuous darkness? Here is the key point in one clear sentence. Even though a dark-grown plant can draw on stored carbohydrates for a short time, it still cannot keep the Calvin cycle running indefinitely because the cycle needs ATP and NADPH produced by the light reactions, and those absolutely require sunlight. Let us build an intuitive diagram. On the left are the light reactions in the thylakoids, powered by photons. They make energy carriers, ATP and NADPH. On the right is the Calvin cycle, which uses those carriers to fix carbon dioxide into sugar. Now imagine continuous darkness. No photons reach the thylakoids, so the light reactions stop. That means no new Calvin cycle fuel, no ATP, and no NADPH, even though carbon dioxide is present. Without those carriers, the cycle stalls. What about stored materials in the roots? Plants can burn stored carbohydrates by respiration to make some ATP, but they cannot regenerate chloroplast and NADPH without light, so the Calvin cycle still runs out of fuel. Step-by-step reasoning. 1. The Calvin cycle uses ATP and NADPH. It does not produce them. 2. ATP and NADPH come from the light reactions that need photons. 3. In darkness, respiration can give some ATP, but not chloroplast and NADPH. 4. Without both carriers, the Calvin cycle stops and carbon dioxide fixation ceases. Let us test the statements. Remain healthy because roots provide what the Calvin cycle needs. False. Roots cannot supply chloroplast and NADPH. Continue to photosynthesize because carbon dioxide alone does not require sunlight. False. Carbon dioxide input is not enough without ATP and NADPH. Not be able to take in carbon dioxide without sunlight. Mostly false. Uptake depends on stomata, but the main block is lack of light reaction products. Not be able to produce chloroplast, ATP, and NADPH. True, and that is the showstopper. Bottom line, in continuous darkness, a plant quickly runs out of the light reaction products ATP and NADPH, so the Calvin cycle cannot keep fixing carbon dioxide. The plant cannot continue photosynthesis or remain healthy